Top Secret Sci-Operative Training Mission. Reading Passage. Bohr Models and Valence Electrons. Mission: understand how atoms are represented in the Bohr model. Then, further identify valence electrons and how atoms become charged. Tips: remember to beam as you read through the passage below.
Hey, Nicole. What's that you're drawing? It looks like a solar system. Is that supposed to be the sun in the middle?
Hi, Aki. It's not the solar system. Dr. Joshi taught me how to draw something called the Bohr model. It makes it really easy to see all the parts of the atom. At the center of the atom is the nucleus, which is made up of even smaller particles called protons and neutrons.
The protons and neutrons look like they're about the same size. What makes them different?
They are both relatively the same size and are small particles inside the nucleus. The difference is that protons have a positive charge and neutrons have no charge. The even smaller particles on the rings around the nucleus are electrons, which have a negative charge.
What's with the rings on the outside, though? It really looks like orbiting planets to me. Are you sure you're drawing this right?
Those aren't planets. They are electrons. Here is Dr. Joshi now. Will you explain to Aki what these rings are on my model?
Nicole, I'm happy to see that you are practicing your Bohr models. Aki, I would be happy to show you how to draw them as well if you want to learn. Atoms are somewhat mysterious. We know that electrons move around the nucleus at the center of the atom, but scientists have been unable to predict the exact path of an electron. What scientists do know is that based on the energy of the electron, they move within certain energy levels. Energy levels are areas of defined energy where electrons are able to move around the atom in 3 dimensions. Different models of the atom represent these energy levels in different ways. Niels Bohr, who created the Bohr model, predicts these different energy levels with rings around the nucleus. Drawing energy levels as rings makes it easy for anyone looking at his model to see how many electrons are in each energy level. But it does give the false impression that electrons move around the nucleus like planets move around the sun.
Dr. Joshi gave me the pattern to follow for how many electrons to draw on each ring. The first ring, closest to the nucleus, can have up to 2 electrons, and the second can have up to 8 electrons. If this atom had a third ring, it could also hold up to 8 electrons. You have to start by putting electrons on the lowest energy level, which is the first ring closest to the nucleus. After that energy level is full, then you can move on to the next. Since I had to draw 8 electrons total, I drew 2 electrons on the first ring, and then I only had 6 left to draw on the second ring. The maximum number of electrons on the second ring is 8, but Dr. Joshi said it's okay to have less.
Filling energy levels. 1. The first energy level closest to the nucleus can have up to 2 electrons. 2. The second energy level can hold up to 8 electrons. Oxygen only has 6. 3. The third energy level can hold up to 8 electrons. Oxygen does not use this level. Great work, Nicole! When drawing Bohr models, you must fill your ring, or energy level, with the maximum number of electrons before starting to fill the next energy level. However, this does not mean every atom has all of their energy levels full or complete. Electrons can have an incomplete outermost energy level depending on how many valence electrons it has. Valence electrons are the electrons in the outermost energy level of an atom and are the ones primarily involved in chemical reactions. Atoms are the most stable when their outermost energy level has the maximum number of valence electrons. Atoms will go to great lengths to be stable.
I would go to great lengths to defeat the hive. What do these atoms do to become stable?
Atoms will either give up their valence electrons or take valence electrons from other atoms in order to fill their outermost energy level and become stable. Valence electrons are the only electrons that can move around easily. This is because, though all electrons are attracted to the nucleus, the electrons on the inside energy level have a stronger attraction since the distance between the particles is less. Since valence electrons are further from the nucleus, it requires less energy to move them. We can see this in the diagram to the right, where the electron closest to the nucleus has a higher attractive force than the valence electrons on the outer ring. The valence electron has a lower attractive force to the nucleus than the electron that is located on the first energy level closest to the nucleus. If an atom loses or steals valence electrons, it will then have an overall positive or negative charge, and now be referred to as an ion. The reason ions have an overall charge is because the amount of electrons and protons are not equal.
How did you know how many electrons to start with?
Elements on the periodic table are neutral. The atomic number tells you how many protons each element has, and to create a neutral atom, it would need the same number of electrons. Oxygen has an atomic number of 8, so I know to start with 8 protons and 8 electrons.
Thanks, Nikole and Dr. Joshi, for teaching me about Bohr models and valence electrons. This gave me a great idea for an upgrade on our gear.
Make connections. In each box below, write a connection between the text you just read and either your prior knowledge or something in your life. Reading comprehension questions. Bohr models and valence electrons. 1. Define an energy level. 2. How are valence electrons different from other electrons? 3. Would it be harder to move electrons from an energy level closest to the nucleus or furthest? Explain your answer. Use the Bohr models below to answer the following questions. 4. Determine the number of protons, neutrons, and electrons in each atom. Fill the table with the number of subatomic particles from atom 1, 2, and 3. 5. Determine the number of valence electrons in each atom. 6. Which atoms had the most valence electrons, least valence electrons? 7. Which atoms would be the most stable? Explain your answer.